Hello and welcome to C Programming Zero to Neural Networks, a series where we learn C programming from scratch all the way up until neural networks. This is part 4 where we will be covering loops. Loops are a very important topic in computer programming. When we talk about doing a million calculations in a second, we don't write out a million calculations and then click run because that would be ridiculous. What we do is we do those things in a loop and get the computer to do the work for us. So let's get straight on with it. Let's do loops. This is going to be a programming heavy video, but let's start with a yellow square. So why have we got a yellow square? Well, we've got a little program here that and we've isolated a bit of the program that draws a yellow square on the screen. There's obviously a bit more to this program than that, and we're going to come back to this program towards the end of this video, and once we've learned a bit about loops, we're going to see what we can do with a yellow square and loops. So let's begin our part. We need to recap first of all. So part4.c file we're making. I'm going to recap what we've learned so far. So we know that we can include parts of the C standard library, such as the stdio.h, which is the standard input-output part of the C standard library. We know we need a main function that needs to be of type int, so we can return a whole number to the operating system, and we return a 0 by convention to indicate that our program has exited successfully. And we've learned that we can use the printf function, so we can print out things like hello world. And we also know we can use ints throughout our program, and we can declare a variable called number of type int and assign it a value of 42. And if we want, in our printf function, we can assign placeholders. Oh, I've just skipped down. Assign placeholders and then replace this placeholder %d with whatever the value number is. So that's how far we've got. Now we need to make some progress. So this is going to be a programming intensive video. We're going to have to cover basically everything about loops. Once again, if this doesn't all go in one video, we're going to be using loops all the time, pretty much throughout, especially when we get to neural networks. We're going to be doing our calculations in a loop, or a variety of loops, or loops within loops. So we'll go over these things again and again and again, and they will go in, I can assure you. But first of all, we're going to make a mkdir makes a directory. We're going to make a directory called notes. And we're going to go into that directory, and we're going to make a file called operators.txt, and we're going to put the operator in that we've already learnt. So we've learnt, so I spell assignment, ASSIGNMENT, assignment operators, and we've got an equals. We've learnt that that's the assignment operator. So when we declare a variable, we can assign a value to it, and we do that with the assignment operator. So we'll call that assign. There are other operators. There's a lot of operators in any programming language, including the C programming language. And in order to use loops, we need to learn a couple more operators. So we've got a comparison operators, or relational operators possibly, depending on your preference. And you'll remember these if you've attended school. We've got a less than sign, less than. We have a greater than, capital. We've got a less than or equal to, and we have a greater than or equal to. So we've got a few comparison operators. We're going to have to list a few more to seeing as we're doing this. So we also have equality operators. We'll just put equality, and we have equals, which is equal to. Different to the assignment operator, a single equals is an assignment, a double equals is an equal to, is a logical operator. Well, it's a comparison operator actually, but it's part of our logic. We also have a exclamation mark equals, which means not equal to. And that about does it for our equality operators. We're not going to do them all, we're just going to list the ones that might be relevant. In all honesty, in loops, we're just for now, in this part, just going to be using less than and greater than, but just to make a few notes. We've also got logical operators, and we have and, which equals and, we have line, which equals or, and we have exclamation mark, which equals not. So that'll about do us for now. It's worthwhile keeping a few notes. If you are determined to become a very good programmer, then keeping notes is handy, especially plain text notes, because if you keep plain text notes, you can use assuming you're programming on Linux, you can use all the Linux utilities, the Linux tools, to be able to search through your notes a lot quicker than you will be able to search through the internet. So I can type, for example, grep -r capital HI and just type in logical, for example, and that'll show me every single file that's got the word logical in it, case insensitive. So I highly recommend keeping text notes. My text notes these days are just little fragments of source code. When I've come up with a good way of doing something, I tend to just sort of save that as it, so I don't have to find that program and find a bit of it. If I need to use it again, I just put it somewhere. Right, so let's return to our program. So where shall we start? Let's start with declaring two variables, int x equals 10, int y equals 20. So we've got two variables, and we've just learned that we've got a few more operators other than just this assignment operator. So we can do x is less than y, for example. But what does x is less than y equal? What does that? We call this a logical expression, or an expression we call it, and we say what does it evaluate to? So what does x less than y evaluate to? Well, a good way to find out is with our printf function. So we can do x less than y equals and then %d. So we're going to replace this %d with a value of some kind, and assuming x is less than y resolves to some kind of whole number, this printf function is going to print it out. So let's find out what x is less than y equals. X is less than y equals 1, strangely enough. What about the other way around? X is greater than y. See what that comes to. That comes to 0. Have you figured out why? It is because we kind of covered this in our last part when we discussed logic gates, when we said 0 equals false, 1 equals true, when we were discussing truth tables. Well, that's exactly the same thing here. So x is not greater than y. So this statement here equals false. And in C programming, false equals 0. And the other way around, x is less than y. Well, x is less than y. X is 10 and y is 20. This statement evaluates to true, which is 1 in our C programming terminology. So that's all we're going to do. We can write more complicated logic, so we can do x is less than y and x is greater than 0, and this will obviously evaluate to 1. And these can get quite sort of seemingly complicated when we've got sort of long chains of logic. But the trick is to read from left to right and just read it as it is. So x is less than y and x is greater than 0. No matter how long these are and how complicated they get, read them left to right and they make perfect sense. Right, so let's get rid of these. We're going to have to introduce loops. So we're going to do, we'll start with a while loop. There's 3 distinct types of loops. So we'll start with while. And that's how we write it. And whenever you're writing a loop, or whenever you're writing anything in programming, it's best to write out the skeleton first. So I'll do that again. Right, while, open close parentheses, open curly brace, close curly brace. And then that's the skeleton of a while loop. It's good practice to do this because you'll reduce how many syntax errors you make. If you try and sort of write the thing out sequentially like you would if you were writing a sentence, and then you're drastically increasing chances you might forget to put the closing parentheses or the opening curly brace or something. So if you write out the structure of it first, then you're less likely to make mistakes. So we want to print out stars. This is the de facto example of explaining loops that you'll find in pretty much every programming textbook, not just C programming, in most programming, anything close to system level anyway. So inside these parentheses we need a condition that resolves to either true or false. So we can demonstrate if we do while false, and then any statements between this open curly brace and close curly brace we call our loop body. So this is the condition in here, and this is the loop body. This loop body will run if this condition is true. So if we put while 0, that's while false. So you can assume that nothing's going to run. So let's try that out. And sure enough, we don't get any output. Shall I zoom in a little bit? Because we might have to zoom out again in a bit. If I put while 1, which is the equivalent of saying while true, then this loop body is going to run forever. And again, we can confirm that. And we just print out stars forever until the computer dies or the electricity in the world runs out or whatever. So what we need is, if we want to, say, with this print star, say if we want to print out a certain number of stars. Well, we can get rid of a while loop. We can do this. We can hard code this. Say we want to print out 10 stars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we compile and run, we print out 10 stars to the screen. This isn't a very flexible program. If we later on decide that we want to print out 5 stars, we have to go in and delete this. Our ideal solution is if we have int num stars equals 10, for example, and then we'll print out, we have one print out star. We want to run this 10 times. That would be a more flexible way of doing of printing out the of running this program, because if we later decide we want to print out 5 stars, we just change one number and the program prints out 5 stars. So how do we achieve that? We achieve that with a loop. So let's do that with a while loop. So we need a condition in here that's going to be true 10 times and then false. So really what we need is another variable, and we're going to make a counter variable and initially set it to 0. So we're declaring a variable called counter of type int, assigning it a value of 0. And we need some kind of condition in here and some way of updating our counter. So let's update our counter first. We can do counter equals counter plus 1. So this will take the value of counter, which initially starts at 0, add the value of 1 to it, and assign it back to the variable counter. So the first time this runs, the counter will be incremented by 1 to the number 1. The next time we run, it will become 2. The next time we run, it will become 3. The next time we run, it will become 4. What we want to do is, in our condition, say counter is less than num stars. So initially this is true. Counter does start off as less than num stars. Counter is 0, num stars is 10. But every time we go around this loop, the counter value increases and eventually it becomes 10, at which point counter is not less than num stars, and this will evaluate to a 0, to a false, and the loop will exit and the program will continue execution down here. So let's try that out. And sure enough, we print out 10 stars. So that's a while loop. And while loops are very useful, especially when we get onto more complex data structures. We're going to find that a while loop is the right tool for the job, often the case. But let's do that the other way around. Counter is greater than num stars. This condition is obviously not true. Counter is 0, num stars is 10. So this, on the first time we encounter it, evaluates to a false. So this is never going to run, and we can try that out. And sure enough, we get 0 stars. What if we want to make sure that this runs once, no matter what the condition? Well, we can't do that with a while loop. So we have a slightly different kind of while loop. We have, let's write the whole thing out again. We have a do while loop, which takes that form. So that's the skeletal structure for a do while loop. It's got do, open curly brace, close curly brace, while, open parentheses, close parentheses, then a semicolon. And just like before, the condition goes in here, but the difference between a while loop and a do while loop is the loop body runs first, then the condition is checked. Whereas in a while loop, the condition is checked first, then the loop body runs. So we can use this in exactly the same way. So we can write printer start. We can do counter equals counter plus 1. And then we can do counter is less than num stars. And this will achieve the same as before. But now, if we do the condition the other way around, so if we say while counter is greater than num stars, which it isn't, that's never the case. When we run this program, we get 1 star because the loop body runs first, then the condition is checked. So the two sort of while loops. We have a while loop and a do while loop. And then we have a final kind of loop. We have a for loop, which takes the form of this. That's the skeleton for a for loop. We also have in a for loop, we have 3 parts to a for loop. So this is a initializer, this is the condition, and this is the update. So the initializer, we can declare a counter variable inside the for loop. So we can actually get rid of that and do int counter equals 0. We're going to have to zoom out a bit here, aren't we? And then the condition is counter is less than num stars, just like before. And then we do counter equals counter plus 1. Zoom out again one more. And we just put our printf in here of a star, and this will print out 10 stars. So that's what a for loop looks like. Now, we use for loops a lot. For loops are great for number crunching. While loops are great for dealing with complex data structures when we get to things like pointers and that. So, although most of the things you can do with a while loop, you can do with a for loop and vice versa. It's about using the right tool for the job. So, for loop's quite flexible. First of all, so a couple of quirks of for loops is, let's say we want to print out the value of our counter. Put that on a new line. We can do counter. Now you'd think that we've got a counter variable here, int counter, and then once we've left our for loop, once we've done that 10 times, we just want to print out the value of it. You'd think that would work. Let's try it out. No, it won't compile. The reason it won't compile is this counter variable exists only for as long as the for loop exists for, and then it is discarded. So we can get around that. We can declare our counter variable outside of the for loop, and then we can print out the value. We can confirm that, and then we get the value that it finishes at, which is 10. We can also omit this altogether and initialize a counter variable outside the for loop, and that will work too, as we will confirm. There we go, it works exactly the same way. Now if you end up doing something like this, you're probably better off using a while loop. We can even omit this, and just like in a while loop, do this in here, and it'll work exactly the same. But again, if you're going to be doing things like this, you may as well use a while loop. We can even omit this, and this is the equivalent of while 1, which will just print out stars forever, as we can once again confirm. I am going through this quite rapidly, but that's because we need to make progress towards our neural networks goal, don't we? And that will print out stars forever. So let's get rid of all that. So let's return to just having a for loop. Get rid of our counter. So for, that's the skeleton for it. Now you'll notice when we do int counter equals 0, counter is less than num stars, counter equals counter plus 1. We've just written the word counter 4 times, and we've made this sort of line of code really long, haven't we? Now for this reason, we generally use 1-letter variable names in for loops. The variable is discarded, this int is discarded once we leave the for loop. It only exists for as long as the for loop exists for, so I don't need to give it too descriptive a name. And the letter I is generally thought to represent the term iterator. So if we replace our counter with I, we've made a much more compact for loop, which is a little bit more readable, and it does kind of make sense. You know, we know that whatever this is, it's a counter variable. It's going to be the thing that we're counting up. So we don't need to explicitly write that it's a counter. Now the next thing is this I equals I plus 1. We do this a lot in computer programming. We do a lot of I equals I plus 1, or I equals I plus 5, or I equals I plus 10. We do it so much, in fact, we have a shorthand way of writing it. We do plus equals 1, or plus equals 5, or plus equals 10. So plus equals 1 is exactly the same as I equals I plus 1. We're taking the value of I, adding 1 to it, and assigning it back to I. It doesn't look quite as intuitive as I equals I plus 1, but you'll get used to it. So we can add this later on to our notes, can't we, as an assignment operator. There's also others. We can do minus equals 1. We can do times equals 1, where we take the value of I, times it by 1, and assign it back. Obviously, times something by 1 is just the same value again. And we can do divide equals as well. But in this specific case of I plus equals 1, we do that so much, increase the value of something by 1, that we have an even shorter hand way of writing it, I plus plus. I plus plus is a post increment, and we can do I minus minus is well. We can even do plus plus I and minus minus I, which is a pre-increment and a pre-decrement. For now, we'll just need this. When we get to needing to use a pre-increment or a pre-decrement, then we'll explain it in more detail then by explaining why we need it. For now, this will do as I plus plus. So this is a really shorthand of writing I equals I plus 1. We can just write I plus plus. And now we've got a really compact loop, and we can print out 10 stars. I won't recompile it again, we get the idea. And that's just a nicer, more compact way of writing it. So let's set ourselves a challenge. Let's say we want to print out not just a row of stars, but like a rectangle of stars, sort of that kind of shape. How do we do that? Well, first of all, we're printing out a line of stars. Let's see if we can print out a vertical column of stars. If we just add in a new line every time we print out a star, sure enough, that will print out a column of stars. So next, what we want to do is print out multiple stars. Now, obviously, we can solve this problem once again by just doing that. And we've achieved our objective. But once again, we've not done it in a very flexible or versatile way. We've hard-coded our solution. We want this to be a solution based on the number of stars. So what we need is another loop. We need a loop inside a loop. And we consider this to be our outer loop and this one to be our inner loop. Now we're going to have to define our parameters for our loop. Int, we can't use I again because even though this variable is discarded, we're inside the loop, so we're still using the I variable. So we need another one. So we generally move on to J. You can use any letters you want for your loop definitions, but I, J, K, L are what most people use just because they seem to make the most sense, don't they? So int J equals 0. J is less than num stars J plus plus. So we're still only printing out one star, but we're doing it 10 times down and 10 times across. Let's see what happens. And we get the right solution. In fact, if we stick a space in there, we can pretty much make a square. That looks kind of squarish, doesn't it? We'll put that back for now. So let's space these things out a bit so we can see what we're doing. So we've got an outer loop, which is counting from 0 to num stars, and num stars is 10, and an inner loop, which is counting from 0 to num stars, which is again 10. So we do 10 down and 10 across, and every time we go 10 across, we print out a new line. Pretty standard textbook explanation of writing loops and using loops. And we'll do the next textbook explanation. What we want to do is print out this pattern. How do we achieve that? Well, if we make one change to this program, we can print out that pattern. So what we want to do is vary the amount of stars that are printed out in our rows. And this middle column deals with rows. We can think of this outer loop dealing with columns. No, dealing with rows, and then the inner loop deals with columns. Sorry, I said it the wrong way around. So we want to vary the columns, don't we? And if we are printing out up to num stars every single time, it's always going to be 10. We don't want it always to be 10. The first time round we want it to be 1. The second time round we want it to be 2. The third time round we want it to be 3. We want it to increase as with each line goes down. And we've got something up here. We've got an I variable that is doing exactly that. It's increasing every time this loop goes around. So instead of doing J is less than num stars, if we do J is less than I have a feeling this is going to achieve the exact result we want. It is. Amazing. So let's do another pattern. Let's say we want to print out this pattern. Let's say we want to print out that. So let's just recap. We've printed out a triangle that way. We basically want a triangle that goes the other way. How are we going to do that? Well, we can't do it with 2 loops. We're going to need an additional loop, but not another loop inside a loop. We just want a loop inside our outer loop. So we're going to have 2 inner loops and 1 outer loop. and this time we're going to have int, we'll go for k equals something. K is less than something, k plus plus. So we just need to figure out what our somethings are, don't we? So the first time round we want to, what we're going to be doing is printing out spaces. So we're doing exactly the same thing, but we want to have the first star, we want to be on this side, not this side. So we need to print out num stars worth of spaces. And then the next time round we want to print out num stars -1 worth of spaces, then num stars -2 worth of spaces. So we need something that goes downwards as the outer loop does its work. And we need it to start at num stars amount, a num stars value. So finally, all we need to do is figure out what the condition is, and again we need to do a comparison to I, because I is the changing value, and if we do k is greater than I, k minus minus, that will probably achieve what we want. Let's have a look. I know that's not probably the best explanation, but I also know that the only way to really get your head around loops is to practice and try playing around with them, and try and make these kinds of shapes. We're going to make one more change to this program. We're going to go back to having a space there, and this time we're going to have an equilateral triangle, and that is basically where we try and get to in our textbook examples. This is the objective that you need to achieve to sort of understand loops. If you can do that, you've understood loops. I thought a lot about doing some kind of like paint explanation for loops, sort of drawing out maybe circles and showing how values are going up and down, but it's best described in code, and the best way to learn loops is to do this. So I would highly recommend, if you're following along with this series and you want to become a really proficient C programmer, a really powerful C programmer, that and you're starting from scratch, which is or you know a little bit but you don't know a huge amount, print out stars to the terminal. And you might not think that printing out stars is particularly advanced program. You might think it's trivial introductory stuff, and what you're learning here when you're printing out shapes, it doesn't really apply when we get to really complicated stuff. I can absolutely assure you it does. It absolutely does. This is key stuff, and we're about to find out why, which is why we're going to go back to our yellow square. So what we're going to do is we're going to do some interesting stuff with this yellow square with using just loops, just for loops. So what we can do with this program, we've got size equals 600 pixels, x equals 0, which is the x coordinate, and y equals 0, which is the y coordinate. And we set a color. If you don't know about colors, these are, the first value is R, red, the second value is green, the third value is blue. So if we change that to 0, we're going to print out a red square. Let's change the size of it to 300 and move it 300 across and 300 down. And let's see how our program looks. We've got a smaller red square which is 300 across and 300 down. Pretty simple, pretty basic stuff. And if we let's change this to blue. If we make that 00255, the range of colours is 0 to 255. It's just like hexadecimal colours, but represented in decimal, if you know your hexadecimal colours. And now we've got a blue square, 300 across, 300 down. So let's add a for loop to this. For a start, let's put this, maybe make a small square of 30. Set the x position to 0 and the y to 600. And let's put the colour back to yellow, because yellow stands out good on a black screen. See how that looks? And we've got a small yellow square halfway down the screen on the left hand side. Let's put a for loop into this program. I is less than, well, I have a predefined constant somewhere called window width, which is the width of the window, as you, I'm sure it's descriptive enough. So we're making a for loop that's going over the entire window width, one pixel at a time. Let's make that. Oh, I have not changed this. Instead of having x, we're going to have I as the x coordinate for our draw square function. And sure enough, we draw a line. Look at that. Not a very efficient program because we're overlapping the every square with another square. We don't really want to go up in there the size of 1. We want to go up as in I equals I plus size. And we can write that in a shorthand way. We can do plus equals size. And this will make the same result, but it's a more efficient program. We're making less steps to achieve the same thing. Really, we want to be able to see each individual square. So we times that by 1.1 by a scale factor. Then we're going up by a little bit bigger than the size each time. And now when we look, we can just about see that we've got segmented squares drawn across the screen. Obviously, if we make that something like 1.7, they're going to be more spaced out and more apart. Already we can do a lot with a square with just a for loop. Let's change that back to 1.1. What about this y value? Well, we can shift it around. We could let's do a bit of maths. We can do tan f times 20. I'll put the value of I in there. Let's make this a bit smaller, otherwise it's not going to work very well. And we've graphed the tan function. If you don't know what the tan is, it's part of trigonometry. If you look at a scientific calculator, you've got a tan button, and it is it's all part of working out angles in right angle triangles. But we're not going to get heavy into the maths, but it's just an example that we, using one for loop, we can graph out some kind of f of x. Let's put that back to y. So let's add another loop. Oh, can't use I again, can we? J is less than, can we guess what we're going to be? Window height, J++. We don't want to do J++, we want to do J plus equals size times 1.1. And instead of having Y down here, we're going to have J. Let's see what happens. Now we've got an entire screen of yellow, but if we make the size a bit bigger, like say 100, we've actually got a grid of squares. 2 for loops have turned a square into a grid of squares. What else can we do? What else can we do to make this program even more interesting? Well, we've got this colour down here. We could vary the colours based on what the values of I and J are. Let's do that in a shorthand messy way. Let's do I divide 7, I divide 7, J divide 7. Let's do that. And now we've got some kind of gradient effect where we fade from blue to yellow. That's pretty cool, isn't it? Can we do anything else? We can reduce the size. Let's make the size 1. And now we've got like a smooth gradient. We've almost made like some kind of Photoshop effect, some kind of a gradient effect, or a CSS effect if you're into your CSS. And if you look at this program, what we started with, we've still got exactly what we started with. In fact, we're not using that anymore. We're not using that anymore. We're just using size. Let's make size 40 for now. We've just added 2 for loops. We've added an outer loop and an inner loop, and we're going across the window width with the outer loop and the window height with the inner loop. This 1.1 and this 1.1, we call these magic numbers, and these are undefined, just random numbers used in our code. We try to lift these out of these kind of situations, and especially because we're using this same value twice. So if we make a scale, in fact it needs to be a float, doesn't it? Float scale equals 1.1. And instead of doing size times 1.1, we can do size times scale. And then we can just change our scale up there. See how that looks? It works exactly the same. We've set the size to 40, and we've now got a grid making application. Out of the ability to draw a square with just the addition of 2 for loops and a scale variable, we now have a grid application that does a gradiated grid. And let's go back now to our printing out stars. It all starts with learning how to print out stars on the screen. And that comes from learning loops and for loops and while loops and do while loops to print out stars. So I've thought about this a lot this video, and I've just ran through basically the textbook example and added a bit of square magic to it. I thought through about 1,000 explanations using Paint of how to describe loops better than what I've just described, where I've just gone through a textbook example. And what time are we on? 35 minutes too long. There's no better way than just writing it out in code. And if this is the first time you've been exposed to anything like this, then the only way to learn it is to do it. So start simple. Let's get rid of all that. Let's get rid of that. Start simple. Print out a star. And then figure out with loops how to print out a row of stars, just like we've done in this video. Then figure out how to print out a rectangle of stars, then a triangle, then the opposite side triangle. And maybe think of other shapes too. We can do is this called a parallelogram? I think this is a parallelogram. See if you can print that shape out. And set yourself little challenges to figure these things out. Like I said, we're going to be using for loops and while loops and do while loops throughout everything that we do on our way up to neural networks. So you've got to start somewhere, and we've got to get into coding because we've got to make some progress towards neural networks, haven't we? And you can consider this to be an introduction once again. Just like when I started on the first video, introduced tons of concepts all at once, and then we spent a bit of time explaining the theory. Well, we're going to have to do the same thing again. So we've introduced very quick run through of using loops to print out stars. And if you're not just watching this as just a bit of interest, and you actually want to attain mastery of the C programming language, this is a good place to start, printing out stars. We're getting the computer to do some work for us straight away. Once we've learnt the relationship between outer loops and inner loops and how they interact with each other and how we can compare our conditions against the condition of the outer loop. Once you've kind of made that leap in your mind and you've sort of grasped that that basic that fundamental idea of using loops to do things, then everything else is going to be loads of other things are going to fall into place and be really easy. So make yourself a notes. Let's go back to our notes before we finish. Go back to our operators. We've got some more operators. We've got plus equals, minus equals, we've got times equals, and we've got divide equals. And we've also introduced unary operators. We have plus plus and minus minus, and we'll put an I there as an example. Put space there, and we've also got I plus plus and I minus minus. This is a pre-increment. This is a pre-decrement. This is a post-increment. This is a post-decrement. And then these, I've never really thought of what to call these. So I'll just leave them as plus equals, minus equals, times equals, and divide equals. If you could think of an appropriate name for them, excuse me, you can put whatever you want in your notes. And that about does it for this part. So a very, very rapid run through of notes, aren't I? A very rapid run through of loops, and that's deliberately so because I don't think there's an easy way to explain it. The best way to explain it is just to keep using them, and we'll definitely be using them. Right, that does it for part 4. I know this has been a bit of a barrage of coding and loops, and absolutely no paint at all. We'll slow down again after this video, but we've introduced loops, and that's a big concept, a big part of computer programming, and we'll go from there. Right, I shall see you next time on C Programming 0 to Neural Networks. All the best.